Hello, you guys. Let's talk about scale drawings. So a scale drawing, like over here, this scale drawing of this airplane, it's a proportional drawing of a real-life object. Obviously, they couldn't fit the real-life airplane on this piece of paper, but they could draw it using a scale. And then a scale model, like these scale model cars, they're proportional models of a real-life object. And then a scale, you need a scale to be able to read the drawing or read the model correctly. And so typically it's the smaller image or shape or drawing over the actual. They use that. And you'll hear me say little over big when we're comparing these. Okay, so take a look at example 1. On a map, the distance between two cities is 3 inches. What is the actual distance in miles between the two cities if the map scale is 1 inch compared to 125 miles? Now, I put a star here. Always, always start with the scale. If they give you the scale, start with the scale. So notice how I used it down here. So I put 1 inch on top of the fraction and 125 miles on the bottom. And then what I did is, see the label of inches? I copied it on the top, inches, and then see the label of miles? I copied the miles on the bottom. And then notice that they started off by saying the distance between two cities is 3 inches. Well, obviously 3 inches is the distance on the map, not in real life. So I put the 3 inches on top and x on the bottom. And then I just used cross products. So x times 1 gave me 1x. And 125 times 3 gave me 375. So the actual distance between those two cities is 375 miles. Okay, so take a look at checkpoint number 1. On a map, the distance between two cities is 4 inches. What is the actual distance in miles between the two cities if the map scale is 1 inch represents 80 miles? So notice again how I start with the scale. I put 1 inch on top over 80 miles, then I put my equal sign, and then I put inches over miles. And so I know the 4 inches is going to go on top, and the x is, I don't know the miles, and then I just did cross products. So x times 1 gave me 1x, and 80 times 4, I wrote down here, and so then x equals 320. So the cities are 320 miles apart. Okay, take a look at example 2, finding the scale. So in a scale drawing, a wall is 2 inches long. The actual wall is 12 feet long. Find the scale. So the solution is when you write a ratio using corresponding side lengths of the scale drawing and the actual wall, and then simplify the ratio so that the numerator is just 1. So all that means is I'm going to take the 2 inches on the scale drawing, I put that on top, and then it represents 12 feet in real life, I put that on the bottom, and then you just have to reduce, but you want to make the numerator, the top number, 1. So I'm going to divide the top and the bottom by 2, so I get 1 inch represents 6 feet in real life. So the drawing scale would just be 1 inch, and then they use a colon, 6 feet. Okay, so look at example 3 with me, finding a dimension of a scale model. So a model of the Sears Tower in Chicago has a scale of 1 compared to 103. Well, the first thing you should notice is there are no units on this, and that's where you'd want to read this little box here. It tells you how they could write a scale without any units, and they explain it pretty well. And so anyway, the scale, sometimes you see a scale like this, 1 compared to 103 with no units at all. The height of the Sears Tower observation deck is about 412 meters. Now 412 meters is a lot, so that has to be the actual height. That's real life. They want us to find the height of the observation deck of the model. And so first we set up a proportion using the scale. So take a look. I set 1 over 103 because that was my scale, equals, and then since I'm trying to find the model, the x goes on top, and the real life, 412 meters, goes on the bottom. And then I just did cross products, so 103 times x gave me 103x, and 412 times 1 gave me 412. And then to find x, I just had to divide both sides by 103, so I found x equals 4. So the height of the model's observation deck is 4 meters. which is still pretty big, but remember that's the model.